briefly talk about gas stoichiometry. In our previous unit we talked about stoichiometry, we talked about if we had X amount of grams of this, how many grams of the other one can we make, or if we have X grams of this, how many grams of this one do we need to fully react with it. In gas stoichiometry, it's a little simpler because if we just know volumes of gases, that becomes a ratio of moles. A magic number for you guys to remember is that 1 mole takes up 22.4 liters at STP. So and again, STP is 0 degrees Celsius and 1 atmosphere. So as long as your STP, 1 mole of gas takes up this. And even if you were at different conditions, it doesn't matter because all gases take up the same amount of space. So you might see a question like this. What if you have 10 liters of C3H8? How many liters of oxygen would you need to fully react with that? So before, sometimes we have to convert like, well, how many grams of this, how many moles we have, and we can do that. We can turn this into how many moles we have. But you'll be able to see since the volumes take up the same amount of space, we can just take the volume that we have and put that above the coefficient. So we have 10 liters of propane. And the question is, well, how many liters of oxygen do we need? We'd set up, we'd cross multiply, and we'd solve for that. We would need 50 liters of oxygen. So again, this is how they did the original stoichiometry to figure out what the actual balance equations were. Is they knew how many liters of one gas react with another volume of gas. So that's what they used to do to figure out these actual chemical reactions, to find these numbers here, what volume of gas is reacted to. So basically, when you do gas stoichiometry problems, just remember that the volumes basically are proportional to moles. We could turn them into moles by dividing both these by 22.4, and that would get you how many moles you have, but ultimately, since you're dividing by the same number, the ratio stays the same, you can just use the volumes.